Studies Section 10. Statistical Estimation. Introduction. The population parameters are often unknown and we may need to estimate them. In this lecture, we will consider the procedure by which we can estimate the population parameter from the sample selected. Specifically, we shall discuss interval estimate of population mean, interval estimate of population proportion, and interval estimate of the standard deviation. Objectives. After this lecture, you should be able to 1. Discuss the difference between parameter and statistic. 2. Distinguish between point estimate and interval estimate. 3. Construct interval estimate for the population mean, population proportion, and population standard deviation. Pretext. To be taken before you proceed to study the lecture. 1. Dash is to population as dash is to sample. A. Parameter statistic. B. Statistic parameter. C. Statistic variance. D. All of the above. 2. Point estimate and interval estimate are the same. In fact, one can be used in place of the other. Yes or no? Content. Section 1. Parameter and statistic. Parameter is concerned with measures of the population, while statistic is concerned with measures of the sample. For instance, in order to study the income level of graduate employees in the private sector, we randomly selected a sample of 1,000 graduate employees in that sector. We then compute their average income and we call it mean. Mean is called a statistic because it is computed from the sample. However, we can use the computed mean to estimate what the real average population income mean is. Mean is a parameter because it is a measure of the population characteristic. Statistical symbols used in representing these measures are as follows. Measure. Size, mean, variance, standard deviation. Sample symbol. N, X bar, S squared, S. Population symbol. N, mu, sigma squared, sigma. Sampling error. In a survey where parameters are unknown, they are estimated from the statistic. The difference between actual value of a parameter and its estimate statistic is what we call the sampling error. Sampling error is function of the sample size. The larger the sample size in a survey, the less the sampling error. By implication, the lower the sampling error, the more the sample is representative of the population. Let us now discuss how to compute this estimate from the sample information. Estimation. As we have discussed earlier, we often wish to get information about a population by studying just a randomly selected sample of it. We say we are estimating the population parameter based on the sample statistic. We can do this in two ways. 1. We can compute a single value from the sample, say the mean, and call it an estimate of the population mean. This is called a point estimate. 2. We may compute an interval of values, say the mean, from the sample dates and say the population parameter falls within the interval. This is called an interval estimate. The second procedure is more preferable because it gives some air of freedom from making a wrong prediction about the population parameter, that is, it reduces sampling error. Consider the two statements below. 1. The average income of some selected employed graduate is 22,000. 2. The average income of some employed graduate in the private sector is 20,000 plus 3,000, that is, lies between 17,000 naira and 23,000 naira. Observe that the first statement is more liable to error than the second statement. Thus, we shall examine the interval estimate in more details in this lecture. Interval estimate of a population. Mean. Mu. Some students often ask the question, what confidence level should I use for my research work? Is it 95% or 99%? Well, there is no hard and fast rule about choosing 0.5 or 0.1. The choice is that of the researcher. What exactly are we talking about when we say confidence level? In a layman's language, when you choose a confidence level, you are only setting a level of accuracy for yourself which you feel your work can achieve. If you choose 95% confidence level, you are only saying that if the task you are performing is carried out 100 times, you are confident that 95% of the 100 will result in the same result you arrived at. Only 5% of the cases may fall outside the range. So, if you choose a 99% confidence level, you are setting a higher accuracy level for yourself. You should also ask yourself, can I achieve this accuracy level? That was just by the way. Let us now consider the interval estimate of the population mean. For a 95% confidence limit, the interval estimate is computed by mean is equal to plus or minus 1.96 standard deviation over square root of n, equation 10.1a. And for a 99% confidence limit, it is computed by mean plus or minus 2.58 standard deviation over square root of n, equation 10.1b, where x bar is the sample mean, sigma is the population standard deviation, n is the sample size. The quantity standard deviation over square root of n is often called the standard error of the mean. If s is given instead of standard deviation, then use s in place of sigma in equation 10.1a. Example 10.11. It was generally believed that the average income of a graduate employee in the private sector has a standard deviation of 5,000 naira. A sample of 80 graduate employees from that sector, however, shows that the average income is 18,000 naira. Estimate the population average income using a 95% confidence interval. Assume that incomes of employees are normally distributed. Solution. Step 1. Write down the formula S bar plus or minus 1.96 sigma over square root of n. Step 2. Fix in the given values. You have been told that mean is equal to 18,000 naira. Standard deviation is equal to 5,000 naira. N is equal to 80. Thus, mean plus 1.96 standard deviation over square root of n. 18,000 plus or minus 1.96 5,000 over square root of 80 is equal to 18,000 plus or minus 1.96, 5,000 over 8.94 is equal to 18,000 plus or minus 9,800 over 8.94 is equal to 18,000 plus or minus 1,096 is equal to 18,000 naira plus or minus 1,096 naira. Thus, the population average income will lie within the interval 16,904 naira and 19,096 naira. 3. Confidence interval estimate of proportions. You need to revisit your lecture note on the binomial probability distribution in order to understand the notations used here. If P is equal to proportion of success and Q is equal to 1 minus P is the proportion of failure in a particular experiment, then a 95% confidence interval for the estimation of the population is given by P plus or minus 1.96 square root of PQ over N, equation 10.2, where the P and Q are as previously defined and N is the sample size. Example 10.2. Assume that PDP is a capitalist party and AD is a socialist party. In an attempt to determine the party affiliation of university teachers, a sample of 800 university teachers were selected and interviewed in Nigeria. Out of them, 510 identified with PDP. Estimate the true proportion of university teachers in Nigeria that identify with PDP. Use a 95% confidence level. Solution. Step 1. Write down the formula. 95% confidence level is equal to P plus or minus 1.96 square root of PQ over N. Step 2. Determine P and Q. P is equal to number of success over total number of trials is equal to 510 over 800 is equal to 0.63. Therefore, Q is 1 minus P is equal to 1 minus 0.63 is equal to 0.37. N is equal to 800. Step 3. Insert the values in the formula. 95% confidence interval is equal to 0.63 plus or minus 1.96. Bracket open, square root of 0.63 in bracket, 0.37 in bracket over 800 bracket closed is equal to 0.63 plus or minus 1.96 square root of 0.2331 over 800 in bracket is equal to 0.63 plus or minus 1.96 square root of 0.000291375 is equal to 0.63 plus or minus 1.96 bracket open 0.01700 bracket closed is equal to 0.63 plus or minus 0.0334 is equal to 0.63 plus or minus 0.03. Therefore, the true population proportion P of university teachers who identify with PDP is estimated to lie between 63% plus or minus 3% or 60% to 65% in brackets. 3. Confidence interval estimate for a population standard deviation. Using the notations you are familiar with, let sigma be the population standard deviation. S be the sample standard deviation, and N be the sample size. Then a 95% confidence interval for the population standard deviation is given by S plus or minus 1.96 standard deviation over square root of 2n, equation 10.3. Let us also illustrate this with an example. Example 10.3. The lifespan of an HIV carrier was measured as the time between infection and death. A sample of 50 HIV patients reveals that the standard deviation of their lifespan is 6 years. Construct a 95% confidence interval for the standard deviation of lifespan of all such patients. Solution. Here you are given S is equal to 6 years, N is equal to 50. No information is given above standard deviation, but standard deviation appears in the formula you are required to use. See equation 10.3. Since the sample size is large, that is greater than 30, we are sure that S will be a good estimate of standard deviation in equation 10.3. Step 1. Write down the formula 95% confidence interval for standard deviation. S plus or minus 1.96 standard deviation over square root of 2n. Step 2. Insert the given values 6 plus or minus 1.96, 6 over square root of 2 times 50 is equal to 6 plus or minus 1.96, 6 over square root of 100. 6 plus or minus 11.76 over 10 is equal to 6 plus or minus 1.176 is equal to 6 years plus or minus 1.2 years. Thus, the lifespan of all such patients is estimated to have a standard deviation between the interval 6 years plus or minus 1.2 years. To conclude our discussion in this section, we wish to remind you again that you may set any desirable level of accuracy for yourself. Whatever level you choose, you can read of the corresponding Z-score on a standard normal table. Meanwhile, some specific levels and their corresponding Z-scores are given below. Confidence level: 99.73%, 99%, 98%, 96%, 95.45%, 95%, 90%, 80%, 68.27%. Z-score: 3.00, 2.58, 2.33, 2.05, 2.00, 1.96, 1.645, 1.28, 1.00. Summary. There are two types of estimates: the point estimate and the interval estimate. The interval estimate is more reliable in social science research. It gives an interval of values within which the population parameter is expected to fall. The information gathered from the sample statistic is used to estimate the population parameter. This is the end of Studies Section 10. Thanks for listening.